All right, so let's go to homework 4. And I guess I should actually tell you a little bit before we jump into it. Okay, let's grab a new sheet. So homework 4 is about discrete probability distributions. Distributions. So we've been doing probability already, but so far all of our probability is kind of been even. It's like, okay, you've got 10 outcomes, then the probability of each outcome is 1 over 10. But sometimes in real life, that's not the way it works. Like, let's say if you roll 2 dice, well, there's 11 different outcomes you can get. You can roll a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, right? Are the probabilities of all those the same? No. Which one comes up the most often, Ann? You've never played craps before? Yeah, 7s come up the most, right? And then 2s and 12s come up the least. So the only way to roll a 2 is double 1. So if I can get my pen to write. I don't know what the deal with this pen is. Well, we'll go ahead and say it while I'm waiting for the pen to write. So the only way to roll a 2 is double 1, so that's 1 out of 36. 3, you can roll either a 1, 2, or 2, 1, so that's 2 out of 36, and so forth. There we go. So 1 out of 36, the odds of a 3 are 2 out of 36, 3 out of 36, 4. I won't write them all down every time, but this is the first example. Let me go ahead and actually write them all down. So they get bigger up until you get to 7, and then they start going down again. 5 out of 36, 4, 3, 2, and 1. So there's 11 outcomes, but those 11 outcomes have different probabilities attached to them. That's the point. The important thing is if you add up all the probabilities, what do you think you get? Well, yeah, if you add up all the numerators, you get 36 out of 36, which is 1, right? And the other thing is that all the probabilities are between 0 and 1. So that's basically what a probability distribution is. You can have the probabilities be whatever you want to, as long as, well, they're all between 0 and 1. And if you add them all up, you get 1. So this is the definition or whatever of a probability distribution. And I would write that down if I could write. So definition of. All right. And most things in life are like this. Very few things are actually even odds. Like you think, oh, if I play the lottery, there's 2 outcomes, right? Either I win or I lose. That gives me a 50-50 chance, right? No. So most of the time in life, you're going to be dealing with things where they're not even odds like that. Let's see if there's a couple of introductory ones, and then we'll talk about mean and standard deviation and that stuff whenever we get to it. The bad thing about them, actually finding the mean and standard deviation is a pain. So we'll have to talk about that. But, well, I was going to let a homework question pull up first, but is it going to? Is it going to? Okay. I guess the first thing we need to talk about is discrete versus continuous, which we did this before. It's like discrete if you can kind of list all the possible outcomes, even if that list goes on forever, it's discrete. If you're talking about something like time, where it's like, okay, well, how fast did he finish the race? It could be, I mean, you can have as many decimal points as you want to, keep getting more exact. That's continuous. So time to upload a file to the internet. Is that discrete or continuous? Yeah, continuous. You can get more and more precise on the answer. So the hair color of adults, strictly speaking, is probably continuous, but it depends. If you name all the hair colors and say, okay, everybody has to be redhead, blonde, or brown, or whatever, then it would. But if you're talking about every little shade of difference possible, then it would be continuous. Okay. Oh, that's a good point. So for purposes of this class, random variables are all supposed to be numbers. So yeah. All right, the amount of rain in city A during July is a discrete, continuous, or not a random variable. So amount of rain, again, if you can extend that out as many decimal points as you want to. So, okay, I'm going to quit answering them. I'm going to let you answer the rest of them. So time it takes for a light bulb to burn out. Continuous. Number of people in a restaurant that has a capacity of 250. Discrete. What if I didn't put the capacity 250? Like you could have any number of people in there. It's still discrete because even though the list goes on forever, I mean, you can still list all the options. And so, okay. The height of a height of a randomly selected person. Continuous. Okay. So that was not too bad. Okay, thought I told it to go to another question. But doesn't seem to be doing anything. Okay, well, while we're waiting for the internet to start working again, let me go ahead and tell you how to find the mean and standard deviation. So the mean, it works just like weighted mean. So if you remember weighted mean, you add up all the possible answers times their weights and then divide by the sum of the weights. We're going to do that here. So the mean is you add up all the possible values for x, and then the weights are the probability of that value. And then you would divide by the sum of the probabilities. But what do the probabilities all add up to? 1, right? So if you divide by 1, nothing happens. So that's it. The bad thing about it, I mean, as we said whenever we did weighted mean, Excel doesn't actually have a weighted mean function in it. So you actually have to go, okay, you have to have one column that has your x, make another column that has p of x, and then you need x times p of x. So you say equals like a1 times b1 or whatever, and then drag that down, and then do sum of that column. All right. So is everybody happy doing that in Excel? We've got enough experience. We can do that one now. All right. Let's see how this is coming along. This is still completely, oh, another question did come up. Okay. Hey, and it's find the mean. So let's do that. So let's open it in Excel. The random variable is the number of girls that Ted approaches before encountering one who reacts positively. That's kind of appropriate for this week, isn't it? So, yes, happy. Oh, what's he doing? Okay, let's do this again. Open in Excel. There we go. All right, so we have the x's and p of x's. So we need to know, hey, what's x times p of x all the way down? It's not typing, is it? Oh, I need to enable editing. Enable editing. Okay, so